What do pollen grains, Einstein, and stock market prices have in common? In the summer of 1827, Robert Brown, a respected Scottish botanist, used his microscope to investigate whether the irregular motion of pollen particles suspended in water was due to their being animated. In fact, he made the same observation of this jittery motion in all kinds of particles, both organic and inorganic in origin. Later on, this phenomenon became known as Brownian motion, or simply particle diffusion. So if it's not because it's animated, what makes the pollen grain move? In 1905, Albert Einstein demonstrated that the motion that Brown had presumably observed through the lens of his microscope was actually the result of myriads of collisions of the molecules of the fluid with the pollen grain suspended in it. Using the mathematical tools that we will introduce in this chapter, he was able to link the macroscopic properties of the process, such as the diffusion constant, with the microscopic properties of the fluid particles. And what does this all have to do with finance? 4 years earlier, in 1901, Louis Bachelier, a French mathematician, analyzed in his thesis the evolution of asset prices in the stock market using the stochastic process. His thesis didn't get the highest distinction, but in any case, he developed the mathematical description of Brownian motion that would later be used by Einstein to demonstrate the molecular nature of matter. The pioneering work of Bachelier in financial mathematics had a strong echo in 1973 when Fisher-Black and Myron-Scholes proposed to use geometric Brownian motion instead of standard Brownian motion to model the evolution of asset prices in the stock market. This would eventually become known as the Black-Scholes model.